My name is Gina Sampedro, so I'm here today to give a talk on reinventing Hello World, perspectives on an AI-driven approach to programming. So I'm actually the founder and CEO of Philippine Coding Camp. It's an online school that started during the COVID-19 pandemic. And I'm also an assistant professor at University of the Philippines, Open University. And I'm also a project leader and a PhD researcher here at Kuma National Institute of Technology here in South Korea. So before my talk, I'd like to give this short quote with all of you. When the wind when the winds of change blow, some people build walls, others build windmills. So currently we have a lot of emerging technologies, some of which might be hard to swallow, but I stand here today as a researcher and an advocate for technology. I want to show you how the things we sometimes see as luxuries or like some things unnecessary are actually needed and catalysts for progress. So, for the agenda of my talk, I'll first talk about a brief history of AI, followed by some AI researches here in South Korea, challenges in AI, as well as opportunities and future direction in this field. So, before we talk about AI, how exactly did we program before? So, before we were often given problems such as this. Given the grade point system on the right, calculate the grade of a student. So it's a simple if else problem wherein you just compare the grade with the ranges of values. So if you were to implement this using programming, you would end up with something like this. If the grade is greater than 96, then this is the grade. If the grade is greater than 90, this is the grade, and so on. Simple problems such as that can be solved without the use of AI. It's basically just simple decision making tools. Or if we're given a problem just like this, compute the Fahrenheit temperature given a temperature value in Celsius. So for problems like this, we just have simple formulas. Simple formulas for computing for the Fahrenheit value in Celsius, such as this. So we just plug in Celsius and the formula, and we get the Fahrenheit value. So that's for traditional programming. What if we're given a problem like this? Determine whether the animal on the right is a cat or a dog. So how exactly are you going to program this? We don't really see numbers. All we see is an image of a cat. So if we're given a problem like this, we might be sweating and frustrated. How will we solve this? But wait, images can actually be represented by numbers. So the cat right here could have an equivalent of these numbers. But did that even help? So we might end up giving up. So how are we going to solve problems like that? So the answer for that is AI. So artificial intelligence is the answer. So what happens when you try to solve a problem like that? So this is actually the machine learning approach to solving that kind of problem. So remember when we were kids, we're actually going to treat our system like a human. So when we were kids, when we learned how to talk, our parents would or our teachers would show us pictures of cats and dogs. And they would tell us that this is a cat. And they would also tell us what a dog looks like. So the main goal in artificial intelligence and machine learning, to be exact, is for us to train the system just the way we were trained when we were kids. So by knowing what a cat looks like, after seeing different images of cats and different images of dogs, we can actually create a formula ourselves. So within our brain, we are trying to recreate a model that can help us determine different features that make up a cat and a dog. So going back to the images, we can probably extract some features like similarities between these cats, probably their ears, probably their whiskers, and for dogs, they also have a distinct ear, they also have a distinct nose, and whatnot. So, by recreating a model within us, we're able to extract features and learn how a cat looks like and what a dog looks like. So, from there, we can distinguish cats and dogs. So the machine learning process is similar to how we were taught when we were kids. So after recreating the model, we can now distinguish what a cat is and what a dog is. But in machine learning, we have quite a problem. So it's actually good that we train our system to know how things work, to know what things are, which is a cat, which is a dog. But if we train it too much, it can also cause a problem. If we teach our system too much what a cat is, what a dog is, and it tends to become biased and it has difficulty identifying other types of animals. So the best way to explain this is actually from a short cartoon when I was a kid. I don't know if you guys remember this, but when I was a kid, there was this cartoon called Dexter's Lab. It's a perfect example for this problem of overfitting. So in the problem of overfitting, again, if we train our system too much, our system tends to become biased. So there was actually an episode before in Dexter's Laboratory. This actually became a meme. Some of you might have already seen Omelette du Fromage. So there was this episode wherein Dexter was trying to learn French and he was listening to a some podcast while sleeping. And for some reason, the file had a problem and it kept repeating the phrase omelette du fromage. And when he woke up, that's all he could say. So, similarly, in machine learning, if we train something too much, it tends to become biased. It tends to just know that. Anyway, enough of that. So, AI. What is AI all about? So it's not something new. Yeah, we see it every day, but this isn't really a new concept. So AI has been around since the 1950s and it has drastically evolved to what it is today. So the timeline you see here is actually the history of AI. So we won't really go through it detailed. But as you can see, it's the development throughout the ages. It has been evolving over time and it can be attributed to what computers basically are. So initially, computers were built to solve certain mathematical problems. They were trained to compute based on formulas. Basically, we have a problem and we have a solution based on a certain set of computations. So we taught our computers how to solve problems by supplying the formulas, the rules. But over time, computers slowly started becoming smarter and they learned to solve problems themselves, thus machine learning, thus AI. So when we talk about AI, before it used to be used for tasks such as solve playing chess. So early applications of AI involve the creation of AI opponents in games. Whenever you try to play with an opponent in an AI-based opponent in chess, so it's basically rule-based. Rule-based in the sense that for every move you make, the AI performs a corresponding move to counter whatever it is that you did. Aside from chess, it was also used for other games such as backgammon, and slowly it evolved to not just games, but even more advanced applications such as in biological engineering, where it's used to identify blood infection treatments. So basically, in AI, we're trying to train a system to think like a human. So let me share with you guys some AI related projects that I've been doing here in South Korea. So some of which are related to education, some are not, and you'll see the value of AI here. So one of the projects I've been working with here is Museo. So for Museo, it's an AI-powered robot that is used to teach children a different language, such as English. So here in Korea, I'm actually building a network of writers who are going to supply conversation materials to the bot, and the bot's going to learn how to talk. And from there, children, parents, people who want to learn English talk to the robot, And the robot responds, and slowly they get to learn English. Because the problem with learning a foreign language, usually when you study it in a country wherein that language is not native, it's hard to learn if you don't have anyone to talk to in that language. That's why with this robot, children are able to learn a different language. Another project I've been doing right now is creating a 3D printer monitor. So whenever a 3D printer prints, it's a continuous process. So even if something happens to the machine, it ends up creating some error, bad output, it still continues. So there's actually a need to constantly monitor a 3D printer, but monitoring a 3D printer actually takes time, money, and a lot of effort. So to simplify things, we created a system that accepts sensor values from the different components of this 3D printer and tries to understand what exactly is happening. So that's where machine learning comes in. So with a set of scenarios, so we have scenarios wherein the 3D printer is working correctly and the 3D printer is faulty. And within those scenarios, we see the different parts of the 3D printer, like the excessive motion, the overheating of some parts, and so on. Another project we're also doing right now is black ice. So black ice, it's a problem in countries with snow. So if you're not familiar with black ice, it's kind of like the areas on the road wherein it's basically ice. You don't know if there's a hole or what. It becomes very slippery and it leads to a lot of accidents. It's a cause of a lot of accidents in here in Korea. So what happens is we're developing an AI based system that accepts camera input and identifies whether certain spots on the road are actually black ice. So if it is, then we try to avoid it. Another project we've been doing right now here is creating a smart power smart power grid. So what's happening here is we try to analyze which different areas need more power than what areas. Because in power distribution, it's a problem in a sense that if you supply too much power to a to an area that doesn't need much power, then you're kind of taking away that opportunity for other areas wherein you need more power. And last project I've also been working with is a project wherein we have drones that move around to areas without much network signal, such as 5G. And these drones have the capacity to spread signal. So they're kind of like signal repeaters. So we need AI driven approaches in a sense that we need to know which areas need more signal than other areas. So, despite all of these applications in AI, there are a lot of opportunities and challenges along the way. We'll start with the challenges. So, in implementing an AI based system, there are a lot of challenges. The process is not perfect yet. There are still a lot that needs to be done, and some of which involves this. So, in AI, we're actually basing our knowledge on historical data. Since we're basing it on historical data, it's important to know the quality of the data. So the quality of the data actually determines how well your system will perform. If your data is kind of biased towards a different area, then your system tends to become biased. So imagine the problem earlier, the problem with cats and dogs. So what if I give my system 5,000 images of a cat and 500 images of a dog? So it's kind of biased towards the cat. And when I test my system, it might end up choosing the cat more because it knows what a cat is more than a dog. So in terms of quality of data, it involves being equally distributed. Aside from that, um, the content should be accurate. Another challenge in implementing artificial intelligence is liability. So imagine a self-driving car. A self-driving car is moving at maybe 60 kilometers per hour, and someone suddenly crosses the road. On the left is an old lady, and the one running on the road is a kid. So who would you hit? So this is a problem. And of course, aside from this ethical dilemma, another issue would be who is liable. So if an autonomous vehicle hits someone, who is at fault? Is it the driver who has nothing to do with who wasn't driving at all? Is it the company that sold the car? Or is it the programmer who developed the software? So there's kind of a gray area in this field. So this is still an issue that needs to be addressed. So if we want to fully implement a smart city, if we want to fully implement autonomous vehicles, then this issue must be addressed. Another issue we see is in ethics. So AI is now being used for decision making. So instead of us providing rules, we provide historical data and our machine learns from it. It learns to make decisions based on what happened before. So AI is also used for in the banking industry. So it's not just in tech per se. It's also used in banking, it's also used in hospitals. So one application of AI is in loans. So banks actually use AI for determining whether someone will be approved a loan or not. So the AI is trained to accept or reject loan applications based on a person's background, based on historical data of people who were approved and denied before. Since we did not provide the formula to our AI system, the AI creates the formulas based on historical data. And if someone was rejected a loan, then how can you explain it? Because it was the AI who came up with a decision. So it's difficult to justify these things. If someone asks for justification, it's difficult because it was just the machine that did it. And we don't think like machines enough to understand why that person's loan failed, especially if his track record is kind of good and not really on the bad side. Another issue in artificial intelligence is privacy. So since we're dealing with historical data, this data is sourced from somewhere. So we have companies like Facebook that tweak the way they market content based on historical data, based on your data. Since it's your data, there is also a gray area there as to who owns it. Because, of course, you produce the data, you technically own it, but Facebook is using it. So, if a company like that is using it without your permission, then it's still subject for debate whether the money they generate from those types of activities, from selling your data, should go to them or to you. And lastly, there are more challenges, but then last challenge we've identified is job security. Since AI is all about automation, allowing machines to make decisions just like humans, then we're technically replacing jobs. So it's still an issue up for debate as to if AI is a good thing or it's a bad thing because it's taking away jobs from people. So a lot of people might say that it's time to upskill. Others might say that it's unfair. And if we address this, then the road ahead would be much smoother. So despite all of these challenges in AI, there are actually a lot of opportunities in analytics. So for the opportunities, I'm going to focus more on the educational setup. So in terms of analytics, we actually see AI being used in learning management systems. So we have AI-driven analytics that allow us teachers to better assess our students. So we see our students' performance, and we get a more comprehensive analysis using AI. So we have massive online open course providers such as Coursera, Udacity. All of these use AI in evaluating essays written by students. So aside from evaluating the performance, we can also assess certain exams. So imagine reading hundreds of essays. So it's quite difficult. So we have AI solutions out there which use NLP, natural language processing based algorithms to extract important content and analyze the meaning of these essays for better analysis. Also, another opportunity in AI is tailor fit education. So given the analytics we collect, so we can tweak the content for our users. So companies such as Duolingo actually use AI-driven algorithms to understand where students focus their studies. So if you tried Duolingo before, if you end up creating a mistake in a certain item, you would notice that it pops up more often. So that's part of the machine understanding that, oh, you need to understand this more before the next step. Another opportunity in AI is universal access. So we have tools which allow us to translate things from one language to another, and oftentimes it's based on AI. It's based on natural language processing. So with this, we have a universal access to education. And lastly, simplified programming. Simplified programming in a sense that when we teach programming, often we focus on technical stuff. And with AI, the students can now do away with those stuff and focus on what's harder to recreate technically, which is the creative side. So despite all of these challenges and opportunities, it's up to us to assess whether AI is the right way to go or not. But for me personally, uh, I believe that the opportunities outweigh the challenges. And this is our future. We will get here one way or another. So it's either we embrace this change or resist it until it's too late. So I'd like to end my short talk with this quote: Be curious, embrace change, and be the change. Thank you.